Professional scientists would love nothing more than to have evidence for the existence of intelligent life elsewhere in the universe. It would truly make them giddy, but such scientists must also be realistic and factual when it comes to analyzing evidence of potential intelligent life on other planets, or perhaps intelligent life that has visited Earth from elsewhere. While the news and TV programs love to gain ratings by sensationalizing reports of UFOs visiting Earth, it is with deep regret that I have to tell you that there is absolutely no credible evidence that a visitation by an intelligent alien life form has ever occurred. Such reports are either complete fabrications, honest mistakes, or can be explained by natural phenomena or man-made objects. So, instead of sensationalizing this lesson about the possibilities of intelligent life on other planets, we'll take a more rational and objective approach to figuring out if such life is possible and whether or not we'll ever find it. First, let us consider that instead of waiting for a civilization to visit Earth, we want to go out and explore ourselves to try and find one. For all we know, the nearest civilization may not be capable of spaceflight just yet, so we'll have to come to them. So, get your wrenches, rocket fuel, metal, and space food and start building a spaceship. Given our current technology and the fastest space probe ever launched, how long do you think it will take for us to reach the nearest star, which is relatively a paltry 4 light years away? It would take 90,000 years. Even if you had some magical ability to all of a sudden travel at even half the speed of light to the nearest star, reaching it in 8 years, you'd need 400 times as much energy as the entire US consumes in a single year to power a 100-ton spaceship. I think we can realistically put the construction of that spaceship of ours on hold for now, don't you? But you can eat the astronaut food if you want. Since we assume that the laws of physics and composition of the universe is the same throughout the universe, we can equally realistically say that the chances that some distant civilization has visited Earth is equally improbable because nothing can travel faster than the speed of light, and the faster you travel, the more energy you need, energy other civilizations and our own may simply not have. Since meeting an alien and shaking their hand, foot, or whatever they greet us with is unlikely, we have to turn to other forms by which we can communicate with them. So, now take your wrench, metal, and screws and let's start building radio telescopes instead. Since electromagnetic waves cannot travel faster than the speed of light, you have to realize that whatever message you send out will take a long time to be received at great distances from us. It will take just as long for us to hear a reply. In 1974, astronomers sent out an anti-coded message, which is a message that can be easily understood by extraterrestrial intelligent life forms about which we know nothing about. This message was pointed at a globular cluster called M13, which is 26,000 light years away. If any intelligent life receives this message, it will look like a picture to them. So, what's the problem here? It will take 26,000 years for any life form to receive it, and another 26,000 years for us to get a reply back. Talk about a communication delay. At least it's better than traveling 90,000 years to the nearest star. Now, although the anti-coded message was a purposeful message sent to ET, we have been somewhat accidentally sending out signals into space for over 60 years by way of radio shows, daytime TV, and whatnot. Thus, if there is an alien civilization within 60 light years of us, and they are advanced enough, they will be able to detect our presence as a result of your grandma's favorite TV program. Similarly, we can monitor for alien civilizations for their daytime TV and radio shows. One famous project called SETI, or Search for Extraterrestrial Intelligence, has tried to do so, but hasn't been successful yet. The problems with any attempt at listening to alien communication is that there is a huge array of radio frequency bands to monitor. Astronomers cannot monitor all of them efficiently. Therefore, the search has focused on something known as the water hole, a window in the radio spectrum with low background interference, which lies between the 21 centimeter line of neutral hydrogen and the 18 centimeter line of hydroxide. H plus OH equals H2O, which equals water, thus the name water hole. We can only hope that an advanced civilization will appreciate the significance of the water hole and use it to communicate with us as well. The other problem with a communication strategy is the fact that there is a constant noise of electromagnetic waves being emitted by our technology on Earth, which is drowning out an astronomer's ability to catch any potential noise coming from ET. As you can tell, like the idea of traveling to meet ET or having them travel to us, the idea of finding a signal from ET is daunting in its scope and fraught with its own pitfalls and problems. In the end of all ends, despite the massive scope of listening to or traveling to a distant intelligent civilization, we can all agree that our chances of actually finding or seeing one, or having one find us, all depends on the number of intelligent life forms out in the universe, and more importantly, in our own galaxy. If there are a lot of them, chances are good we'll get a signal from them as soon as they hear our radio babble from 60 years ago. If there are very few of them, we may never find them at all, either because they're too far away or because we destroy ourselves before then. Actually, that brings me to a pretty well-known, albeit controversial, equation called the Drake equation, an equation that estimates the number of communicative civilizations in the Milky Way galaxy. This equation has a factor in it that essentially estimates the amount of time a civilization survives to be able to communicate with distant civilizations. Meaning, if most communicative, intelligent civilizations die off before having enough time to find life on other planets, or enough time for us to detect their communications, then their existence is basically null and void in the grand scheme of things. The Drake equation has optimistic and pessimistic outcomes. In the best case scenario, there may be an intelligent and communicative civilization within tens of light years from us. This means we should be able to find them in a few decades. On the pessimistic end, we may be the only such intelligent life form within thousands of nearby galaxies, and we may never find ET, especially if we self-destruct sooner than later. Flying off to meet ET on their home turf isn't a realistic possibility right now. It would take way too long. We can try to communicate with ET in hopes of finding them faster. In 1974, astronomers sent out an anti-coded message, which is a message that can be easily understood by extraterrestrial intelligent life forms about which we know nothing about. But even this message will take 26,000 years to reach its destination. We can also simply listen for signals coming from them. One famous project called SETI, or Search for Extraterrestrial Intelligence, has tried to do so, but hasn't been successful yet. One reason it's so hard to find signals from ET is because there are just too many radio frequency bands to monitor. Therefore, the search has focused on something known as the water hole, a window in the radio spectrum with low background interference, which lies between the 21 centimeter line of neutral hydrogen and the 18 centimeter line of hydroxide. The other reason it's getting harder to hear stuff coming from ET is because our own technology produces signals that are constantly trying to drown out any signals coming to us from space. But finding any signal more than likely depends more on how many communicative civilizations are even out there. For this, we can turn to the Drake equation, an equation that estimates the number of communicative civilizations in the Milky Way galaxy. The best case scenario implies that we'll find evidence of ET within a few decades. The worst case scenario may mean it'll take far longer. Perhaps we'll never find one, even if it's out there.